What questions do you have for me on the page? Feel okay about it? Anything you want to go over, even though you had an answer you're still not sure about? Yeah.
Number 4.
4.
Would you do the solid point?
Yeah, that's a great question. Thanks for asking. Yeah, so if you have it like this, you're going to look in the x direction for -8, and it's the solid point, so that definitely comes out to the -3. Yeah, that. So you remember when they say, hey, is the graph a function? There was something called the vertical line test. So we have the missing dot, but then the solid dot right above it. That still makes it a function because you don't count it twice. But yeah, that's a great question. Yeah.
What do you do for 10?
10. Oh, number 10 says the limit as n goes to -infinity. Is that what it is? F of x. Okay, so like the back part of the graph, you kind of have this, the 0, and then it goes like this. Okay? I think this is going to go forever in that direction. I think we've seen all of the turns and stuff. So it's going upward forever. So this is going to be going to positive infinity because it's heading up. Does that make sense? Okay. Yeah.
I can do 6.
6, yeah. Number 6, limit f of x as x goes to -2 coming from the positive side, so coming from the right. So -2. Okay, so at -2, you have this doing that, and then you have the other graph doing something kind of like this, right? Okay, so we're coming from the right, so we're on this graph. So where does this seem to be heading towards? Infinity. Yeah. So this is going to infinity. So yeah.
2 and 3.
2.
It's the number it's approaching, right?
I'm sorry?
So for example, 2 is approaching from the right.
Yeah, 2 is approaching from the right, and 3 is approaching from the left. Yeah. So here, I'll just work those both real quick. Number 2, limit as x goes to -8 from the positive side of f of x. And then number 3, the limit as x approaches -8 from the negative side. So our graph at -8 does this. Something like that. I'm not perfect. And then, yes, we have that dot right here. Okay, so this one from the positive, this is coming from the positive side. Okay, so that's going to be -6. And then if I'm coming on this one from the negative side, that goes to -6 as well. So it's the same for both. Hey, Ethan, did you have the homework from last time?
Right.
Okay. When you get done, you go ahead and do it. Or show me when you get done. Any other questions off that homework? You feel okay? Happy? Everyone's content? All right. So, I am on the page that says limits 4.1. At the very top, it says business calc and limits 4.1. Okay, so the main thing is if it gives you like h at some number or f at some number, a lot of times you're looking for what the dot is. It could be, though, it could be the graph. It could be the graph on both of those, but just in case you don't know that, so that should take care of you on those first couple. And then some other things to know is when you're dealing with the limit, sometimes you can do some number. Sometimes you can just plug in the number. and get the limit. Okay? Sometimes you can't. The times that you can't plug in the number is if it makes, the times that you can't plug in the number is if you have a denominator with the variable down there, and by plugging in, you get 0 in the bottom. So if that does happen, there are some tricks that you can do. Like you can see if you can factor it and cancel out binomials. You see if you can just reduce the fraction somehow. But I hope you remember that you can't, if you had something like this, x squared minus 9 over x minus 3, and let's say, no, I'm giving you a problem. I didn't mean to, but so this limit is coming from both sides. If we plug 3 in right now, the bottom becomes 0. Okay? So please don't, you have to make sure that you factor where you can. And again, you can, if you're not good at Desmos, or if you're not good at factoring, you can use Desmos. So once you get this type of situation, this created a hole, which is fine, but then you can just plug into this, and that would give me an answer of 6. Okay, because 3 plus 3 is 6. So sometimes you can factor. Now, there are times that it won't factor. I don't think you're going to run into it with this class, but there's different rules in place that as you get into something called a derivative, where you take the derivative of things, and a derivative reduces the exponents, and then you try and see if something will cancel out that way. Sometimes you take a second derivative and keep going. There are sometimes that a limit just won't exist. But the big thing about a limit won't exist if you had this, let's say this, if this is equal to both this and this, these both give me the same number. So this means I'm coming from the right. And this is coming from the left. That's supposed to be a negative right here. Coming from left. If that happens, and it happens to be the exact same number, that means this is coming from both sides. Where that won't take place is if you have a situation where the graph does one of these. Let's say you had something drawn this way. If this is the value we're trying to figure out, this is our question mark. This is our x value. X approaches the question mark. If I come from the left here, this y, if I come from this way, so if I come from the positive or come from the negative, being that they are showing up at two different locations, the limit does not exist. Okay? So your limit wants to show up at the same place. Now, it's possible that it'll say, hey, what is the limit as I'm approaching from the negative side? That limit exists because it's bound by that. But if you have something like this, this means, and there's nothing up here, they don't have no signs, that means you're coming from both sides. Okay? If it has a sign, that means you're coming from one side or the other. So a lot of times we'll give you, so let's say we had a similar scenario. We had this versus this. Let's say that this was drawn. And let's say that we know that this is the point, say 2, 5. And then this point here is 2, 1 or something like that. If I did the limit as x approaches 2 from the negative, my answer would be 5. If I did the limit as x approaches 2 from the positive side, my answer is 1. But if it's stated like this, as the limit approaches 2, this means I'm coming from both sides. But because I come to two different locations, you're on each graph. I'm coming to two different locations. this means this. This one here, the limit doesn't exist. So the limit can exist if you're definitely knowing you're coming from a side, but this one does not exist because it goes to two separate places, whether I come from the left or the right. Okay? All right. So we can do that. Cool. All right. So let's have us do the page 4.1. I'll give you a lot of time to work on this. You can do all of them, but skip 7. Actually, no, you can do 7. Never mind. I misread it. It should work. So do them all. I'll give you the opportunity to work on it. Why don't I give you like 5? Let's give you like 10 minutes to get a start. If you come across some questions, then ask and we'll go over them as a class, okay? Okay, friends, what do you see? What can I help you with? Any of those sticking out?
You do 11.
11? Sure. Let's take a look at number 11. Please write down whatever you need to write down for number 11. So the limit as x goes to negative infinity. So this means that we're going out that way. Okay? So the first thing I would do is check to see if this is going to reduce down at all. It's not looking like it. So this would be one that I would say, let's bust out and take a look at the graph on Desmos. Oops. So we have y equals parentheses 5x raised to the third minus 4x divided by 2x raised to the third minus 2. Okay, so if we look at our graph, let's make it bolder. You're seeing everything that's really going to take place with this graph. So as I go to, it says negative infinity.
Oh, yeah.
So this line's kind of growing, but I'm not sure how much it's growing. Let's see. Let's see if I zoom out a little bit, see if it's definitively getting towards a value. I'm going to go out here to like negative 50, and then I'm going to zoom in there. So negative 50 is pretty far out, right? You agree with that? So where's this going? So it's going to 2.499. So as we keep going further and further and further, you can twist the system, say, you know what, let's go out to a lot further. Let's go out to like negative 500. Negative 500. Look at my y value is 2.5. So we could verify that if we go on even further out. Yeah, let's take it out to negative 2100. Notice it's still 2.5 in the y. I bet you our limit's 2.5. Okay? Does that make sense?
Yeah.
So I use the graph to kind of tell me, I mean, negative 2100 is not negative infinity, but negative 2100 is pretty far past that wall, right? So that's what I would think about. Any others you want me to help you out on? Seem okay? Yeah.
Number 8.
8. Oh, okay. Number 8. So they have R at t, so that's just the same thing as y equals 128 t squared plus 6t over t squared plus 6t plus 18 quantity squared. And they're saying this is taking place between 0 and 8. All right, so if we wanted to find for A, the limit as x goes to 4 of RT, which is our equation, we might be able to directly plug that in and see what happens. So I would plug 4 into all these t's, see what happens. So I'm going to get 128, 4 squared 16 plus 24 over t squared, which is 16 plus 24 plus 18 quantity squared. Someone have a calculator do that real quick. 128, 16 plus 24. I can pull it up on mine. What is it?
5,120.
5,120?
Yeah, if you're doing 128 to the full times 40.
You did this,
Oh, the bottom 40.
the whole thing. Let's see.
5,120 over 3,364.
Over what?
3,364.
Okay, do me a favor. Will you reduce that? Go 5120 divided by 3364. Did you get
1.52?
1.52? I'd say you'd say the limit there is 1.52. It doesn't matter which way you're doing it. And then letter B, they say find the limit as x goes to 8 coming from the negative side of RT. This one, I would just go ahead and plug the 8 in for the t's as well. And let me just grab my calculator real quick. Hey, thanks for doing this, guys.
Hi, Sarah. How are you? You need to update me about the download.
All right, so I'm just going to plug that in on my calculator. Being that I'm doing direct plug-in, it doesn't matter if I'm coming from the right or from the left. I'm just going to plug in the 8 plus 6 times 8 divided by, enter, divided by 8 squared, so that's 64 plus 48 plus 18 quantity squared. So if I do this one, it's coming out to 1.14 roughly. So both seem pretty legitimate. They work. Cool. Anything else? You feel okay about it? Yeah.
I thought you said not just plug it in.
So sometimes you can directly plug it in, especially if you're not looking at a graph. Okay, like you could have went ahead and graphed that, plug in x in for substitute x in for t. You could have graphed it, and let's take a look at the graph, see what happens, and maybe Stirrup is totally wrong, but I think I'm okay. But let's see. I'm gonna go y equals parentheses 128 times x squared plus 6t or 6x divided by x squared plus 6p or 6x. Oops, that should be a plus. Let's see, plus 6x plus 18. And that quantity is squared. All right, so we're looking at 8. Okay, so I'm just going to write this in here. I'm going to go x equals 8. Okay. So I'm just drawing a vertical line in there just to say, look, first off, does this graph, if I came from this way versus this way, go to 2 different locations? Seems to go to the same point. So if I click on that point, 0.848, I would think I was off on my 0.848. Ooh, I did my math wrong here. 0.848. Or did I plug it in wrong? 128 t squared plus 6x. Got it. T squared plus 6x. Yeah, I must have been off. I would definitely graph that and take a look at that 8. So it definitely goes to the exact same location. So the answer to letter B on that one should have been 0.848, not the number I gave you. I guess I didn't do my math totally correctly, which sometimes my arithmetic sucks. Sorry. Any other questions off that? You feel comfortable with it? Good to go. So we are finishing up. This is now our second week of school, right? Or is it the third week? Second week. Third? It's the end of the third week? Really? Oh, cool. All right. So that means, yeah, so that means next Friday we will have another real life application of math. We're going to actually do something called fair division, which is how you, it has to do with inheritance and how inheritance works, especially if somebody doesn't have a will that says anything definitively, like, Billy gets the house, Johnny gets the 5 cars. If it doesn't have it in place, it tells you how to break up an estate fairly amongst a certain amount of people. If the will basically said, just divide the estate up equally amongst everybody. And it's actually I'll make it kind of silly, goofy. I mean, if you were here for the last one, you saw that I was kind of silly and goofy about who was our salesman we used last time? I forget. Rex? All right. Rex from Jersey. So you have the rest of the period to work on that. If you need any more time or any help, let me know. I'm happy to help you.